Okay, we are on to page 3 of our review. We're looking at question number 9, and the question reads, what is the equation in slope-intercept form of the line that passes through the point 12, 5 and is parallel to the graph y equals 2/3 x minus 1? Okay, so lots of information here. Just take it piece by piece. Don't be intimidated. It says, what is the equation in slope-intercept form? Okay, so slope-intercept form is y equals mx plus b. Okay, passes through the point 12, 5, which is our point is x1, y1. Okay, and is parallel. Okay, parallel to the graph, so we know parallel lines have the same slope. Okay, so they didn't give us the slope of the line, but they did tell us it had the same slope of another line, or was parallel to the other line, which means it has the same slope. So in this case, hey, looking at this equation they gave us, y equals 2/3 x. My slope here is 2/3. So a slope of a line parallel to this line would be the same, 2/3. Okay, so parallel lines have the same slope, so that's what we're looking for. Okay, so now they're asking us for slope-intercept form, but take a look at what they've given us here. We now have a point. There's our point right there, and then we also have a slope. So let me see if I can get this pen working again. Apologize. Our slope right here. So when we have a point and a slope, and they want us to put it in slope-intercept form, the easiest thing to do is to start off with point-slope form. Okay, so if we look at our formula sheet that we're given, point-slope form, okay, let me write this down here. Okay, our point-slope form is y minus y1 equals m times x minus x1. Okay, and we use this form when we have a point and a slope. Okay, so pretty simple, straightforward. So I'm with y minus, my y value is 5 equals, my slope is 2/3, and then x minus my x value is 12. Okay, so I want slope-intercept form, this y equals mx plus b, but when I'm giving a point and a slope, it's often easier just to put it in point-slope form and then convert it back to slope-intercept form by solving for y. Okay, so you should be familiar with this. I'm going to set y minus 5 equals 2, I'm going to distribute that 2/3, so that's 2/3 x minus, distribute that 2/3, 2/3 times 12. I'm going to set that 12 over 1, so it's easier for me to solve that. Okay, continuing with my solving. I now should know that I can say y minus 5 equals 2/3 x minus, when I multiply out my fractions, that's 24 over 3, or 24 divided by 3, which is 8. Okay, so a couple of different ways you can do that. You can reduce it down, or just multiply straight across the top, straight across the bottom, and that's going to give you y minus 5 equals 2/3 x minus 8. Now I can add 5 to both sides to solve. Okay, so now I'm left with y equals 2/3 x. Negative 8 plus 5 is a negative 3. Okay, and that is the equation of my line in slope-intercept form. Okay, again, take it piece by piece. They're asking you for slope-intercept form, so you know you need to have it in y equals mx plus b. They gave you the point xy, which was 12, 5. They told you it was parallel to this graph. Parallel means they have the same slope, so we just pulled this slope here from this equation, and then we plugged it in and solved for y to get us back into slope-intercept form from our original point-slope form. Okay, pretty straightforward. It's a lot of steps, but it's straightforward. Okay, So our next question, number 10, says, what does it mean for a system to have infinitely many solutions? Okay, referring back to your notes, infinitely many solutions. A couple of terms we have here. Basically, it's an identical line. Okay, so infinitely many solutions would be an identical line. Okay, another way that's written is coinciding lines. Okay, so they may not appear to be the same line, but they would reduce down to the same line. For example, if I had y equals, if I had a line y equals 2x plus 3, and that would be plus 3 right here, up 2 over 1, okay, up 2 over 1, blah, blah. Okay, there's your line. Okay, I can have another equation where I multiply that entire equation by 2, and it would have 2y equals 4x plus 6. Okay, and maybe I manipulated this equation a little bit to make it look like 2y minus 4x equals 6. Okay, these two lines don't look like they're the same, but this one and this one. But if I solve for y on the second equation, I would come up with 2x plus 3. Okay, so that's why sometimes it may not look like they are the same line or identical lines because the equations don't look the same. But once you simplify and solve for your y, they end up being the same equation. Okay, so that's what identical lines would look like, or infinitely many solutions. It's basically if I graphed the second line, it would be directly on top of this line. So there would be another line just right over the same identical line. Okay, so that's it for number 10. Let's take a look at number 11. Okay, scroll up. Again, don't be intimidated. Just take it piece by piece. In this equation, it says to write the equation in slope-intercept form. Okay, so that's something I want to identify there. Let me see if I can get this pen working again. Slope-intercept form. Okay, slope-intercept form is y equals to mx plus b. Okay, it says, and the line passes through the point 5, 1, so that is x1, y1. Okay, and it's parallel, so parallel means that it's the same slope. The same slope to the line represented by, okay, this equation should say y equals, so I'm going to set that y equals 2. So if it is represented by that same, you got this parallel to that line, then a couple things we know, or one thing that we know, is this is my slope of this line. So the slope of this line is 1.4, and if the line is parallel, then it would be the same slope. Okay, so we know that this is the slope we're looking at for our new line. Okay, so we know we've got the slope, we've got the point. Okay, so they want our answer in slope-intercept form, but we have a slope and a point, or a point and a slope. So the easiest thing to do here is to set up our point slope form, which is y minus y1 equals m times x minus x1. Okay, you're given this equation for your test. So y minus our y1 is 1. Okay, over here from our equation. Come on, pen. And our slope is the same slope as the other line, so 1.4 x minus 5. Okay, now this is point slope form, but they're asking us for slope-intercept form. So all I need to do is solve my equation for y equals mx plus b. So I've got y minus 1. I'm going to keep y minus 1 on this left side. I'm going to distribute on the right side. So y minus 1 equals, if I distribute this 1.4, it's 1.4x minus 1.4 times 5. Okay, all I did was distribute it here and here. If I simplify that, y minus 1, come on, pen. Y minus 1 equals 1.4x minus, and 1.4 times 5 is 7. Okay, now I'm almost there. If I add 1 to both sides, add 1, y equals 1.4x minus 6. And that is my equation in slope-intercept form. Okay, on to question number 12 on page 3. Okay, it's our last question for this page, and then we'll go on to page 4. Okay, same thing. Again, just read carefully through the problem. What is the equation in slope-intercept form? So you've got slope-intercept form, which is y equals to mx plus b. Okay, you've got a slope and a y-intercept of the line that passes through the point 2, 3. So that is our point is 2, 3, which is our x1 and our y1 value. Okay, that's the x and y value of a point. And then it is perpendicular to the line represented by this guy right here. Okay, so y equals 3 over 5x plus 2. Okay, we know that perpendicular lines have opposite reciprocals. Okay, opposite reciprocal slopes. Reciprocals, I'm going to abbreviate that. Okay. Opposite means if one is positive, the other one's negative. Reciprocal means we flip the numerator and denominator. So if this equation has a slope of 3 over 5, then a perpendicular slope would be negative 5 over 3. Okay, so this is what we're looking at. We've got this point and this slope. Okay, they're asking us for slope-intercept form, but they've given us, or that we have the information for a point and a slope. So the easiest thing to do is to write point-slope form, which is y minus y1 equals m times x minus x1. And you are given this formula. Plug in what you have. Y minus a negative 3 equals our m is negative 5 over 3. And then x minus our x value is 2. Okay, so now that simplifies to y plus 3 equals negative 5 thirds x minus 5 over 3 times negative 2 over 1. I'm just distributing that negative 5 thirds. So y plus 3 equals negative 5 thirds x plus 10 over 3. Okay, so when I multiply the negative 5 thirds times the negative 2 over 1, that's 10 over 3. Okay, I now need to subtract 3 from both sides because I'm needing to solve for y. So minus 3, oops, come on now. Minus 3, minus 3. Okay, so I'm going to bring that over here. Y equals negative 5 thirds x. I have plus 10 over 3 minus 3. Okay, I need to get a common denominator so that I can add those two fractions. I have a plus 10 over 3. I'm going to change this to minus 9 over 3 so that I can combine these two guys. When I'm adding and subtracting fractions, I need a common denominator. So I'm left with negative 5 over 3x. 10 over 3 minus 9 over 3 is a positive 1 over 3. So this is my final answer. This is the slope-intercept form, okay, of an equation of a line that passes through this point and is perpendicular, which means opposite reciprocal slope of this line over here. So if this line has a slope of 3/5, then a perpendicular slope would be the opposite reciprocal, -5/3. I have a point, I have a slope. I can put that into point-slope form and then convert to slope-intercept form by solving for y. Okay, a lot of work. It's not hard, but there's several steps involved, so you need to have enough practice to be familiar with this type of problem. Okay, we're going on to now our last page of our review.